Let's go. Wow, that's good. Okay, so we do this little program that's called mockups, and it's a wireframing tool for creating UI wireframes. And the title of my talk is Refactoring a Classical jQuery Multi-Page App into React plus FLUX One-Page App. But really, what I wanted to call it is Indiana Jones and the Raiders of the Lost Model, because I've given a talk about React already a few months ago, and at that time it was just an introductory talk about React. So I showed the way that React works, and I said explicitly, and I would say it again, that React is only is a very good library for dealing with the view. But you know, this is JavaScript MVC meetup. So where is the model and the controllers? Where are those? And so that's what we're looking for. So I was working at a project with the React this winter, and yeah, I find myself in this situation. So basically, yeah, as I said, the React is very good for building a view, but then Flux is the thing that comes into play when you really want to structure your application, and that is the lost ark that we're looking for. So yeah, this is what I was working on this winter, and it's a new buy page of our website. So this is where you go if you want to buy our product, and this is all built with React. And of course, it's not too complicated. It's just a few things here and there. But in the end, I ended up structuring my code in such a way that really resembles a lot with the Flux architecture. And of course, unfortunately, they started talking about Flux when I was almost finished, so I couldn't apply it. What I'm going to talk about today is this very simple UI. So this is instead a part of the My Balsamic website. So all I'm going to talk about tonight is production work that I'm really working on. So it's real stuff. And basically, My Balsamic is a website for the hosted version of our product, and you pay a monthly fee. But if you have previously bought a desktop version, desktop license, you can register into your console, and you can redeem half of the price. So basically, this is just a simple screen where you have the list of your license keys, and you can click on this button to add another one. And if you do, you're going to see a dialog with the name and the key, and then you click add the key, and it hopefully is going to appear next with an increased amount of savings because you are redeeming more money. So that's what we're going to look at tonight, and I'm going to show you the code for how it's currently, how it was implemented before. And then we're going to go through the process I went to convert it to React. And the first thing I've done was collect all the data into a nice JSON structure, and we'll see that. And then I actually built the new React view. And then I introduced the Flux architecture to deal with the opening and closing of the dialog, so something that has to happen. You do it with Flux, and then how to talk to the server. Actually, the interaction with the server to check the license. And so let me show you what it looks like. So this is the code. This is the markup. So basically, My Balsamic is implemented in Grails, which is a framework that is made after Rails, but it's implemented in Groovy, which is a language that runs on the JVM. And so hopefully this is just one of yet another markup language template. So you will understand probably. So there's a guard up here that the whole thing shouldn't appear if this is a free site. And then there's some more markup, and there's a title. And then there's a test here because we have a few warnings like this one that should appear only in special cases. So there's a couple of if statements basically. And then the interesting bit is down here, because if you are allowed to see this part, then again another test, then you see the title, your license keys, and then there's this for loop, an iteration that iterates over the keys, and then formats them nicely with some markup. And then down here there's the add another link. And you can recognize the familiar ID attribute, way of doing things, because then we will have some jQuery code that will try and reach to this tag element to attach a click event handler. And then, well, then in the end there's the savings total amount, and so you can see that there's these operators here are just access source for information that's available from the Groovy code. Those are basically ARM objects, so it's all ARM. And in the end, there's a little configuration for the dialog, and this is going to be also a jQuery dialog. I think it's going to be Bootstrap or something like that. So this is what the markup looks like. And then we have, let's take a look at the server-side code. This is the server-side action. It's implemented in Groovy, as I said. So there's a little bit of reading from the database and reading again the keys, the license keys, and then those are made available to the GSP page. This markup that we've seen before. Oh, I didn't mention GSP stands for Groovy Server Pages. So it's, instead of JSP, it's GSP. So. And then this integer amount, this currency, and then some more information. So this is all stuff that needs to be made available to the GSP. And then there's of course some JavaScript, and it looks very much jQuery style. At the end there's the access sort to the link for adding a new license, and this is the click handler. If you click on it, it will open a dialog. And the configuration of the dialog is up here. So there's going to be some, width and height, whatever. And then the cancel button, which will close the dialog. And the add key button, which will make a few sanity checks. And then we'll make an AJAX call. The AJAX call to this URL that, again, is built dynamically, because this is not JavaScript. Really, it's a dynamic JavaScript. It's generator server-side, so it cannot be put on a CDN if we want to. But, that's a different story. Arguable, but we can always do better. And then these are the parameters, name and key to the AJAX call, and then this is the handler of the result. Let's take a look at what the server does when it's called. This is the action, this add key. It's long, but it's not so scary. So again, there's a little bit of fetching stuff from the database, and then this action will always return 200 status code. Again, this could also be made better, but this is the way it works currently. And it's going always return a JSON. If there's a problem, it's going to return success false with a message saying what was wrong. Otherwise, it will return true. And so there's a couple of sanity checks here, and then if there are exceptions, then they are caught and a message is formatted with the success false. And if everything goes according to the expectations, then you will get a message saying the license was added successfully, and a new URL is created. And that's actually really the same URL of the page you're in right now, because all you need to do is reload the same page to actually show that now there's one more line in the list. And indeed, if we go back, we see that in the handler, if it was a success, then we reload the page with the URL that is being given to us by the server. Otherwise, we just show that what was the error with this message. And this turn on and off pubnub is interesting. We use pubnub. I don't know if you guys know it. It's a service for server-side off-band asynchronous events. So it's the kind of stuff that you can use when you want to show a pop-up dialog saying, "Hey, your colleague made this change to this mockup," or so stuff that comes up. You can use this service, and this has to be turned off when we trigger this AJAX request, because if everything goes right, this will end up reloading the page, and during the time that the request is fired and then the reply comes back, you don't want any notification to appear, because otherwise it's going to be lost when the page reloads. So, you know, a little nuisance that is all going to go away as soon as we move to a one-page app style. So, so this is the code, the status of the code as it was before I started working on it. And then the next step, as I said, is we should collect all the data that we have scattered around in GSP code into one nice JSON structure. And let me show you what I mean by this. Basically, if we go back to this GSP code, we see that this is you know, some information we need. It's a Boolean variable. This one, another Boolean variable. This one is a string. You know, all sort of things. And we can actually put them all together in this structure down here. So basically, I changed the server-side action by adding this config variable, which is really just a JSON string with all the information that I know I need on the web page. And so this is free, is trial, the billing admin name, the owner name, and you know, the list of the keys and everything else I need. The URL that I want to publish the request to, and then on the markup, this is what all is going to become. So basically, the way I work when I you know, migrate the code from the old style to the React is that I focus on a specific component, and in this case is the one that I showed you, and then I create another one right next to it with React, which is going to look exactly the same. So in my page, there's going to be a time when I will see two exactly identical sections, and when I know that they work exactly the same, then I remove the old code and I get rid of it, because then I use the new one. And this is what it will look like. So basically, it will look like just one simple div, and that's it, with an ID that I will need to, because I need to fetch it. And then there's going to be a data attribute with the JSON structure that I just created. So that's where I'm going to put the JSON string. And then I use AMD style modules, so with require.js or whatever you prefer to use. And this is the module where I defined the React component. And so basically I fetch the JSON configuration here, and I pass it on to the React component when I instantiate it. And then we render the component with this call. So at this time I should ask, how many of you actually have ever read about React or know a little bit about React? So you guys maybe understand this little this few comments up here. For all the rest, I will not go into many details, and I will not explain how React works. So try to follow up anyway. But basically, this is how you. This is one of the ways you can instantiate a React component, and you will see what a React component will look like. And now, basically this was wrapping all the information inside a nice JavaScript in JSON structure. Then we actually need to implement the real component. So this is what a React component looks like. So this stuff you see here is called JS. It looks like HTML. It's the fact that you can write it intermixed with JavaScript is a feature that's called JSX. And basically, it's an extension to the language that React library makes possible. So this source code is parsed and then converted to actual JavaScript, but it's really a minor conversion. So, and it's just a convenience for writing a little bit of markup. And a React component needs to have a render method that is called when it needs to be rendered. It needs to become DOM. And basically, there's a guard up here that says, if this is a free site, then you should render to nothing. This is equivalent to this tag up here that we've seen. So this tag was saying, if it's free, then render nothing, and the equivalent is this one. If it's free, then render nothing. And the rest is exactly the same. So there's the markup. The title, and then some more stuff here, except for these lines here. This is what React makes available, makes possible. So you can embed function calls in the markup so that it reads better. And these are the two warnings that may appear, and they are guarded by these checks. Yeah, you have a question?
So the view is actually in JavaScript?
I'm sorry?
So the view is in JavaScript?
The view is in JavaScript, yes. So that's one of the very strong and opinionated points about React. So it's their deliberate decision to intermix the markup with the JavaScript code. And I believe it's a powerful decision, but with great power comes great responsibility. So yeah, so it's this is a good point actually, because the whole thing is that you should not write your components in such a way that everything is tangled together. So you should not have both markup and logic in the same component, right? That's why we are looking for the model. Right. So this is the theme of my talk. So where is the model? So let me just quickly go through the rest of the implementation, just because I wanted to show you. This is the other warning, and then there's the render keys with a guard, and this is the for loop, let's say, that iterates over the keys, and for each one of those creates a markup. And the markup is wrapped around this other one here. And then there's a total down here. So, and this is it. So basically, when we're done with this, we are back to having this. So if I could run it, you would see that basically now there's two of these. One is the old style GSP, and the other one is the React generated view. Now what's missing is some functionality, and that's when, because the reason why it's missing is that down here where there's the link to add another, you don't see any event handler here in the tag, right? So we haven't implemented it yet. So now it's a good time to talk about FLUX. So the FLUX architecture works this way. So we have views, and the view looked like the one I just showed you. And the views are supposed to fire actions. The actions trigger execution of something in the stores, and the stores are the model. So we're looking for the model, and the stores in the FLUX architectures are the model. So the stores is where you want to keep your application state. So the views, in response to user clicking or something happening, fire actions, and the actions make something happen in the stores. When the stores update their internal state, they emit events, so that the views can again re-render themselves, and then you will actually see what has changed in the stores, because you will re-render it. So since many of you don't know React, let me mention one important thing. So basically, the strongest point about the React library, the way it works, is that basically you're always supposed to re-render the whole thing all the time, because what really happens is not that markup you've seen goes straight into the DOM. That would be obscenely slow. So what instead happens is that a virtual DOM is created, and the virtual DOM, and that's really fast. So creating a virtual DOM is really fast, and because it's only in JavaScript, pure JavaScript. That virtual DOM is compared to the previously generated virtual DOM, and only the differences are applied to the DOM. So that's what makes React so fast. So basically, whenever you change something, maybe you change one number in the total amount, and that's it, and then you re-render the whole thing, and the library will figure out that only that number has changed, and it will only update that node in the DOM, and it will be blazingly fast. So this allows us developers to write the view in such a way that is much simpler, because basically we don't write explicit code like we do in jQuery, for example, to deal with the events. Like for example, you open a dialog and then you close the dialog. So in jQuery, you're going to write a lot of code that looks like destroy the dialog, because you have to intercept the click on the cancel, and then you will have to destroy the DOM element that represents the dialog, right? We've all done this. In React, you don't do it. In React, you just flip a Boolean flag somewhere that says that that dialog shouldn't be rendered anymore, and the next time you render the whole thing, including the dialog will not be there anymore, and so the library will figure out that the dialog has to be removed from the DOM. So you don't have to explicitly code stuff to deal with, like remove or add a class, remove a class, or destroy the element, create the element. You only describe how the entire thing should look like basing on your state, and the state stays in the stores. And so we have, actions and events. But really, the two things, actions and events, are really publish-subscribe patterns. Yes?
If you compare the virtual DOM to the real DOM, do you compare the virtual DOM of components or from the whole application?
Well, it depends on what you re-render. So if you re-render, so you have a stacked, you have a nested structure of React components, and depending on which component you fire the re-rendering process, then the whole subtree will be re-rendered, including the children, and that's going to be the virtual DOM that's going to be compared with the previous one. So you can be, and you should be, actually try to be smart and decide to re-render only the components that you really need to, but you can also just re-render every time the whole application. If it's not really complicated, very complex, very dense, of little things, if it's not too, you will not notice the difference. It's so fast. So yeah, actions and events both are publish, subscribe, observable pattern. Call it the way you like. The way they're different is that actions are dense with content, and events are very simple. They're just strings. Basically, they're just a name of something that happened. So the stores emit, so these are the emit and on are the actual method names. And so emit is, stores emit an event, and just is just a string that identifies what has changed. You just need to know what has changed, because then the views can subscribe to those events with the on, and then we'll know that they have to re-render themselves because they have given that event. And the actions instead are dispatched by the views, and the stores register to the dispatcher in order to receive the events. And events are, and actions are much more dense. They're much more, carry more information. They actually have a payload. So not only a name, but also maybe some more information. And we will see an example of that. This is another way to see, oh man, this is dark. This is another way to see the same concept. So basically, the stores are your model, so your inner part of your architecture, and those should be totally independent of all the rest. And then you have the views outside that fire actions into the store so that the store can update themselves. And then the stores, it doesn't have to be only the view, it can be the network, for example. So if you receive an asynchronous event from the network, that's also going to be an action. Or maybe you want to model an AJAX call with an action, with a response, you can also do that. And of course, you can have tests that work this way. So the stores should be they're really testable, because you can inject actions and see what happens. Because then the stores come out with events when they change, and so then after the event, when you receive the event, you can go back and check what happened to the store. So, but really, what is this Flux architecture? So, oh man, this is dark, but that's Indiana Jones. So where can I download the Flux framework? So the thing is that really it's not a framework. Flux is nothing. There's nothing to download. It's just good old software engineering. Really, Flux is a talk, basically. If you go to the website and you look it up, it's just 2 pages of documentation and a link to a talk. It's a good talk, so I advise you to watch it. But that's all that there is to it. And people have been actually showing you know, what they've done, the way they've implemented Flux, and so you can download their stuff. But there's no one Flux framework to download. It's just, you know, a good way to implement your code. And you probably end up doing something like this anyway if you try to roll your own. It's just a very sensible way to do things. So let's see what it looks like. So first of all, we have to, so the goal here, mind you, is to let the dialog appear when you click add the license, right? So we need to trigger the, you know, the visualization of the dialog. So first of all, first thing we want to do is bind the view to the events. So we hook up to the emitter with an on license change event. This is the string that we make up. So we make up this string to identify the event, and when we receive that event, what we want to do is force update. So this is React. It's a React method. When you call this function here, force update, that's what, you know, the re-rendering. It will force the re-rendering of the component. And then in the render function, we're going to need to add the actual dialog, which I'm not going to show you, like the actual markup, because I just stole it from Bootstrap, but you know, you get the picture. And this is the interesting bit. Basically, in the render add dialog, this is what I was talking before. So we know that we need to render the dialog by looking in the store. So we decide to store the Boolean variable, whether the dialog should be shown or not, in the store, and we will have to implement a method in the store that gives us that Boolean value. And if the dialog has to be shown, then we render the component. Otherwise, we render nothing. And then in the render keys, when there was the add another link, we finally implement the click event handler. And in the handler, we just fire an action that we will call show dialog, and we pass the Boolean variable true to that action. And we will see how that action will look like. In the dialog, conversely, there's going to be a cancel button that will just fire the same kind of action but with a false value. So it's, you know, show the dialog, dismiss the dialog. And the action looks like this. It's very simple. We just hook to the dispatcher and we dispatch a new action, and you see the action is simply a JavaScript object, nothing more, with an action type that we also make up, show license dialog action, and we attach the Boolean variable shown. And so let's look at the store. This is the store. Again, very simple. So this is the Boolean variable that we were talking about. So this is the authoritative source of the information. Where do we say whether this dialog should be shown or not? Here. This is the store. And so we initialize this variable with false. And this is the getter to get the current value. And then this is the register function. So in this naive implementation of Flux, every store receives every action. So we have to filter what we're interested in. And so with an ugly switch statement, we switch to what we're interested in. And in case of show license dialog action, what we do is we pull out the value from the action object and we put it into the variable. And then we emit the event. So this is closing the circle, remember? So when we were, now where is it? There you go. So basically, here we fire the action to when we click the add license, and then we show dialog true, and it goes this way. Then the show dialog Boolean variable is updated, and then an event is emitted, and so the view will re-render itself. And this is the way it works. Now we might want to also add complete the circle and also talk with the server. So let's look at what it will look like. But in order to do that, so we need to change something, because if you remember the way that the application looks like, there's a list of licenses. If we also model, if we're going to model also the interaction with the server, eventually we're going to have 3 licenses, right? If we add another one. And so this means that the information about the licenses needs to be also in the stores, because it's a mutable variable. It's got to be something that needs to change. Instead, right now it's hard coded. It's hard coded in here. If you remember, this is the main entry point. So basically, we were fetching the configuration, the JSON configuration, and inside the JSON configuration there was the list of the keys. And this is, you know, hard coded and passed as a property to the React component, and you're not allowed to change those. So we need to change that, and we're going to change it this way. So basically, we still read the JSON from the configuration, but then we implement an initialize method in the store, and we pass the keys to the store so that we make the store the authoritative source for that information now, right? And along with the URL, we probably need that too, and the rest remains the same. In the view, we change this bit here. Instead of accessing it from the properties like before. This is before, remember? So this props is the way you access the properties in React. So whatever information you pass to the constructor of a React component, you can access it via the props. And this is, you know, immutable. So you're not allowed to change these keys. So this is not a good place to have something that needs to mutate. This is the better way. So we actually ask the store, and the store, you know, of course can change it. And so this is what we change. And then we have the license key dialog. This is, you know, I'm going to show you some partial implementation because it can be interesting as an example of a React class. This is the, so we need to model the temporary typing of the information in the dialog in the two fields. So this is how you model it. You get an initial internal state with empty values for those fields. And this is just a trick for focusing automatically. When you open the dialog, it's already focused on the first field. And then you have these two input fields. This is how you show what's, you know, yeah, okay, I'm almost done. This is how we show the value, and this is the change event handler. And the event handler is simply changing the internal state of the React component. And this is how we keep track. You keep this information here in sync with whatever the user is inputting in the controls. And then the on-click event handler of the add key button is bound to this function, which fires an action to close the dialog, just dismiss the dialog, and then we'll create another action for adding a license with those two information. Now let's see what the actions look like. This is the new action. Again, we dispatch a very simple object. We make up a new name so that we can distinguish, and then we bind the two information that we know we need. And the store finally changes this way. So basically, we add these two new more information that we need to manage with the store. And this is the initialize method that we saw before, and we simply, you know, store the keys in that variable. This is the new getter for the keys, and this is the new dispatcher for this action. We're going to call this utility function down here, which is the one that makes the interesting stuff of making the Ajax call. It's going to be a post to that URL with those two variables. And then with the response, we always show a notification. And if the response is successful, then we update the keys and emit a new event. And that's it. This is all it takes. Again, I just remade the same loop of creating an action on the view that is fired in response to some event like clicking. The action makes its way through the dispatcher all the way to the store. The store intercepts the action and then performs some work. And when it has changed its internal state, it will fire an event. And in response to that event, the views will render themselves again. So this is it. And as I said, really, there's nothing about it. It's just good old software engineering. To recap, the observer pattern. The observer pattern is used to decouple the view from the business logic. and it's very good at that. The state must reside in stores, unless it is very view specific. This is an important point. So basically, if you had seen my previous presentation about React, you would remember, and we've seen it shortly here also, that basically React components have an internal state. And you may wonder whether you should save the information in the internal state of the components or outside in the stores. And the answer is that really you should store it inside the component only when it is very specific to this view. Like for example, let's say we have a multi-state checkbox that can be checked, not checked, or maybe gray, stuff like that. That's something that might very well stay in the internal state of the component, because it's just no one else cares about what's the state. Maybe you will access that information when you need to maybe submit the form. Then you make it public, but otherwise it will stay view specific. But let's say that this checkbox is part of a panel that needs to, you just watch the panel. You're implementing a web app that you're supposed to watch the panel, and something else happens somewhere else. Maybe some other user flips that switch, and you want to see it updating because you have server-side updates. So in that case, that would not stay in the view anymore. You need to put it in a store, because then you know that you also have the network that needs to update that value. So it's not like you have to see how your application works. But in general, I find that there's very few things that need to really stay in internal states of the React components. And then this is also the one of the, so far this is just a plain software engineering concept. So this one is more a little bit of the Facebook, Instagram guys idea, and I think it's a good idea, that actions that go from stores from views to stores should be information rich. Those should be information rich, whereas the events that notify the views from the stores, those should be dump. And this is not obvious. At least it was not obvious to me. Like if you come up with an architecture yourself, like I did several times, you may come up with a way to notify the views in such a way. You figure out I'm a store, and this variable, the dialog shown has changed, so I'll notify my views. You may decide to implement events that also carry the information. Right, so the dialog visibility has changed, and now the new value is true. So if you do it, you're gonna walk down a dangerous path, because then you will structure your views in the wrong way. So the way you want to structure your views is that and you're going to do that if your events you keep them dumb. The way you want to structure your views is that they always refer back to the stores for accessing the information. So you want to have your events very dumb, so that the views are forced to go back and check on the authoritative source, which are the stores. And this is pretty much it. So this just as a closing slide, there's the module dependency graph of what I ended up having. And the view is really the only part of my component, the architecture that depends on everything else. And it's the only thing that I'm not interested in testing. The other ones are really highly testable, but because they're pure JavaScript, and so all the business logic stays in the store, and it's really easily testable. Then we may wonder, okay, we found the model. Where is the controller? I don't know. I don't know about the controller. So you may have stores that are very smart, and like the way I like to implement them, they can also know how to do stuff. Or you may have separate components to do the controller part. That's up to your application. So you will see. But the important thing is that you want to keep the view very separate from all the rest, and you want the view to access the stores as a source authoritative information. And that's it. Thanks. Yeah, go ahead.
So, does React play nice with stuff like 3JS and D3? Because I can imagine you might not get any speed boost there. Because every time you re-render something, like the whole thing has to be re-rendered, basically.
I'm sorry, with the 3JS?
Yeah, that's WebGL.
Oh, WebGL. I don't know about WebGL much, but I know that you can do SVG with the React, and I know that it works well.
Okay.
So if it's the same, then it might work. But I'm not very. I'll try. Yeah.
what makes things really complicated are intermediate states, like showing the preloader when the data is being saved and all this stuff. And how would you do it with this Flux model? I mean, like, show the preloader while a JAX request is sent to the server. And
show a loader. Yes, I do it all the time. So it's actually quite simple. You could do something like this, for example, in the in your store up here when you fire the AJAX request. So we may have, for example, something like this. Loader, actually loading, which is normally false. Then in the AJAX request, you say loading equals true, and then you emit an event, because then your views will update. And of course, you need to change the view so that you will check whether the loading has to be, the spinner has to be shown, right? But there's a variable right there. And then you can do something like this. At the end. So basically, you just, you start, you change this variable at the beginning of the AJAX request, and then you change it back when you're done. And every time you emit a new event, and so when you emit, you know that your views will update. And so in your view, you will have to maybe somewhere up here in the render keys, for example, you will well, I don't have the code right now, but you can have, or maybe here, our spinner equals license store get is loading. Then you show a spinner, otherwise nothing, and then you put it here. That's it. Does that answer your question?
Yep.
Yeah.
Why did you reinvent the wheel with Flux and not use a framework like a backbone?
That's a good question. Well, I personally, because the approach that I tend to like, to prefer, is the Unix approach, where you have different tools. Each one of those does one thing and does it very well. And then I like to put them together myself. So in my case, I like React because it takes care of the view, and that's the only thing that it does, and does it really well. And then I like to choose myself how to structure the rest of the application. And for applications like these ones that are not too complicated, I must say that I don't think you need much support from a framework. And so I like to roll my own. Also because rolling my own just means writing this kind of code, which is not too much, I think. But then yeah, I can totally see how in different situations you might want to leverage the knowledge that is being built inside a framework. If you do some consulting work, for example, and you implement repetitive websites for different customers all the time, then you want to be very fast and you don't want to reinvent the wheel every time. So I understand. For a greenfield project or application or product like this one, so I think framework, in my opinion, is overkill. But that's my opinion.
Plays well with existing framework?
I think so. I've read of people doing mix and matches of everything. Yeah.
I'm just curious what you think of sort of the maintainability of this stuff. Like, imagine your company finds somebody else to fix a bug or add some new functionality to the work you did. Do you think that this approach sort of survives that test?
I think it improves it, because if you don't use a framework, then all there is to know is in the code base. Otherwise, you face yourself the challenge of figuring out all the magic that the frameworks implement most often. So for example, I never learned Angular. If I had to look at Angular code, I would put my, tear my head, because it's really hard to figure out what kind of magic is happening at some point because you don't know the framework.
Do you think, so if somebody new is jumping into this kind of code that you wrote, would you send them to these Flux talks first?
Well, of course, you know, all the background that's available, of course, I would reference it to them. But even if they didn't have access to it, the nice thing about this is that, and I find myself actually being that guy sometimes, because I go back to projects that I wrote like maybe 2 years ago, and who remembers what I wrote, what kind of crap I did. So I like the fact that I see this license store is loading. What is license store? So I go up here in the chain, and it's, well, not in this file, but I go up in the chain and I see that the license store is a module. Oh, okay, so that's a module. So I go and look up for the file in this file system, and I see that the module is this one. Oh, there you go. Oh, is dialog shown? This is the function that I was looking for. So everything is self-contained. So there's nothing, there's no function call, no method call in the code that I just wrote that is not also being defined in the same code base. So I'm not facing any magic. The only thing that I need to learn, because it's not in my code base, is these methods that are part of the React library. But that, of course, is documentation that one has to read. So I will say, you know, go read the React library. It will take you a couple hours. So at least you know what component did mount is and what it's supposed to do, and then the rest you will figure it out.
Yeah, there is a built-in solution in Angular and React that you use React for rendering views. It's very nice for performance, and for stores, like you write your own, you can use Angular services and factories and just put to your React classes, you just put Angular scope and work with it inside your view. This way you will solve this problem.
Yeah, absolutely.
Be very well structured. You will have a list of services which you use inside your view to render modules, and just pass here Angular scope.
Yep.
Are you using any other add-ons or plugins for React, like React routing or something? Router?
No, I'm not. Like, are you making it up, or did you read about some?
Yeah, I
thing?
read about it.
Oh, okay, so maybe I want to read that too, because I'm not familiar with it.
Yeah,
but no,
his
I'm not.
question was like, if you're building a more complex app,
right?
Why aren't you using a framework? Or
A router is definitely a component I would like to look at, because. But I believe you can have. I mean, I would be looking for a router that looks like a library more than a framework.
Oh,
so
yes. Yeah.
yeah, exactly. So I would definitely look for something like that. Okay. But in my case, so far, no, I'm just using some simple plugin stuff for maybe what's it called? For there's a utility helper for building classes. Some simple stuff, so not using nothing specifically.
Whenever you're deciding to choose a framework or a library or whatever, with React you think of creating an application that is very small and not complex. But whenever you choose a library that is meant to build a complex app, would you still choose React? Or?
Oh yeah, absolutely.
Yeah.
Even more so. The difference that I mean I've never been a framework guy, but the reason I think is because I was never a consultant, properly defined consultant, like doing repetitive work in not in a bad way. I mean, like in my life I work on 2 products, and when you do product work, you don't care much about the framework because you're not going to leverage the advantages of a framework anyway. And soon enough, you will find yourself fighting the framework. This at least is my experience. So if you do a product development, then you might as well start greenfield and roll your own thing, because it will pay back in the end in terms of internal consistency. And but then if you need to work for a lot of different customers and very often do same sort of stuff, then you're going to bore yourself to death if you don't use a framework.
Right.
Then a framework is definitely worth using, I think.
I think if there are any other questions, we can come.
Yeah, absolutely. Thanks a lot.